Hey, in this video we talk about solving integrals by using integration tables. The thing is that since the invention of calculus, people have been solving integrals, and they also noticed that some of them are rather difficult to solve. So why not collect those which we can solve in tables, in long tables of integrations? In fact, there are even books. So for example, here's one, a rather thick book which contains lots and lots of solved integrations. And also in our textbook at the beginning, we have a table of integrals about 4 pages long, and it contains lots of stuff. So let's have a look at this table. So here is the table of integrals from our textbook. They are numbered, and you see number 1 is just the integral of u dv, which is uv minus integral v du. Na, does it look familiar? It's the integration by parts rule. And then here integral u to the n is 1 over n plus 1, u to the n plus 1 plus a constant. This is the power rule. Here with the integral of the log, integral of the exponential, integral of sine and cos and secant and cosecant and all these wonderful functions. But this goes on. So then here are integrals which have a term of the form root of a square plus u square. And then there's a whole variation of those where this can arise. And we will do examples in just a second. Here are those ones which involve a root of a square minus u square. Here is the opposite, u square minus a square. Here is terms of the form a plus bu, etc., etc., right? And then here come lots of trig function, cotan to the power of 3. Wonderful formulas. So we have all these formulas available and many more. So if there's anything you can't solve, you find it here, or if you find it there, you can still go online and just type in table of integrals and you will find lots and lots and lots. So what I like to do now is just to use a table of integrals to solve a few integrals which might actually be more difficult otherwise. So let's start here. Evaluate integral x sine x dx. How would Tolo solve this? Well, one idea is integration by parts. Let's see if Tolo is up for integration by parts. Hi, Tolo. Oh, you look rather tired. Oh, I see. You rather look it up on the table. Because entry number 82 is exactly this integral. U sine u du is sine u minus u cos u plus c. Done. Here's another one. Integral x squared divided by root of x squared minus 2. Oh, wait a second, I just showed you integrations which involve the term root of x squared minus something. And after close inspection, I find that formula 44 is actually the best choice here. We just need to identify that x is u, and the 2 becomes the a square, so a would be root of 2. So we can simply copy this formula. So we have integral then x squared dx divided by root x squared minus 2 to be equal to x half root of x squared minus 2 plus 2 half log of x plus root of x squared minus 2 and then plus the constant. And then you can simplify this is equal to 1. You can leave it out. But that's it. So just identify the u's and the a's and then use the formula. But it's not always that easy. For example, the integral of sine of root of x is actually not in our table of integrals here. But we can get it there by doing a substitution. We choose u to be root of x, then du is 1 over 2, 1 over root x dx. And solving this for dx, we get dx is 2 root x du. But root x is u, so we can write this to be 2u du. Substituting this all into the integral, we get integral of sine of u, and then the dx transforms into a 2u du. Then we have 2 integral u sine u du. And this is the integral we just solved with Tolo's help by looking up formula 82. So here's 82. And then we can just continue down here So then this equals sine of root of x, you know, u is root x, minus root x cos root x and the lovely constant. And one more. So again, this 1 over x squared minus 4x to the power of 3/2 is not in the table of integrals. You can look as much as you like. So again, we need to use a little trick. And here the trick is completing the squares. So we complete the squares. We consider x squared minus 4x, only this guy, and I write it to be x squared minus 4x. Okay, and then to complete the square, I need to have the 2, I need to divide the 4 by 2, which gives 2, and then square it, so I need to do a plus 4 and a minus 4. And then the first bit is in fact x minus 2 square. And then I keep the minus 4 from the back. All right, are you with me? Good. So then we can plug this back into the integral, and we get integral dx divided by x minus 2 square minus 4, and then all this to the 3/2. Okay, now we can go back to the table of integrals, and we find it's still not there. Meh. Okay, so then we have to do another step, which is a substitution. We substitute u is x minus 2, du is dx. Going back to the integral, then we get integral du divided by bracket, and then so u is this guy, so u squared minus 4 to the power of 3/2. And now this is an integral which we have, which is integral 46 in the table, where then we need to identify a to be 2. Okay, we can just copy this formula over here, and we get this is minus u divided by a squared is 4 root of u squared minus 4 plus a constant. And as a final step, we have to make the substitution backwards. So then we get minus x minus 2 divided by 4 root of x minus 2 square minus 4 plus a constant. Again, so the tables can be very helpful. And as I mentioned, there are lots of them.